Alright, in this video we will practice solving a system of equations involving conic sections like circles, parabolas, ellipses, and eventually hyperbolas. But just like we did in the previous video, in this video we're going to find the intersection of a line and a circle. If you did not watch the video for problem number 1 first, you should probably watch that first because I went very slowly and I explained in great detail. This is problem number 2, so I'm going to go faster. Okay, so there are two methods. We can solve this algebraically using substitution, or we can solve it graphically. Well, actually, for this assignment we have to do both. So I'm going to start by solving this algebraically, going to do some substitution. On the one hand, we have this simple equation y equals negative x. So that's great. I'll set that aside. On the other hand, we have this. This is in standard form, which is great for graphing, but for substitution, it would be helpful to not have this in standard form. So I'm going to rewrite this in general form by understanding that x minus 6 squared is x minus 6 times x minus 6. Alright, I think I'll do a different color so I can keep it separated. Y minus 1 squared is y minus 1 times y minus 1. Then of course we have our equals 25. So you have to do a double distributive property here. X times x, that's x squared. X times negative 6 is negative 6x. And then you do the distributive property again with the negative 6. Negative 6 times x is negative 6x. Negative 6 times negative 6 is positive 36. And now I will do the same thing with the y's. Alright, I'm going to do y, distribute the y. So y times y is y squared. Y times negative 1 is negative 1y, or just negative y. Then I will distribute the negative 1. Negative 1 times y is negative 1y, and negative 1 times negative 1 is positive 1. Okay, we have like terms here, so this is going to make x squared minus 12x plus 36. And we have like terms here, so this is going to make y squared minus 2y plus 1. And then that's equal to 25. So it's time to do our substitution. We know that negative x, y equals negative x. Y is already by itself. So what I can do is I can take this expression and substitute it for y in this new equation. So I have two different y's. So I'm going to have to take this and substitute it in both places. Okay, so I'm going to have my x squared. Let's see, can I do this simultaneously? Yeah, I'll just keep going like this for a minute. I have x squared minus 12x plus 36. Okay, now here comes the substitution part. So I have plus y squared minus 2y. Notice how I always use parentheses when I'm about to substitute. You should do the same thing. Put parentheses where the variable was. So I've got plus 1 is equal to 25. Okay, and then so inside of here I have my negative x that I'm substituting. Okay, so let's begin to clean this up. So I've got x squared minus 12x plus 36, and now I've got well, negative x squared is just going to be x squared. Okay, because negative x times negative x is positive x squared. This is going to make positive 2x. Alright, negative times negative is positive. Now I've got my plus 1 and equals 25. Alright, so now it's time to put together all my like terms. So for example, I have x squared here and here. So let's put that together. So that's going to make 2x squared if I put those together. Alright, then I have my negative 12x and my positive 2x. Those get put together. That's going to make negative 10x. Alright, negative 12 plus 2 is negative 10. Alright, then we have our constant terms. So I've got my negative 36 and my positive 1. So that's going to make 37. So I've got plus 37, and that's all going to equal 25. So somehow I need to solve this equation. It only has x's in it, so it should be doable. When I notice that I have x squared and x, then I know I'm going to need to solve by maybe factoring, or worst case scenario, we'll have to use the quadratic formula. So I like to try to factor when I can. But first of all, I'm going to need everything on one side for this. So let's subtract 25 from both sides. So that's going to give me 2x squared minus 10x and then plus what is that, 12? I mean, no. Okay, so I have this. Once again, notice that all three of these are divisible by the same number. They're divisible by 2. So make your life easier and divide everything by 2. Okay, so that is going to give us x squared minus 5x plus 6 is equal to 0. Okay, now I'm going to try to solve this by factoring. So let's see if we can rewrite this as a binomial times a binomial. So when I look at that x squared, I'm thinking, okay, that's x times x. When I look at the 6, I'm thinking it's either going to be 2 times 3, or if that doesn't work out, I'll try 1 times 6. Now the inner plus the outer has to give me the middle. So right now, inner, I have 2x. Outer, I have 3x. I need that to make a negative 5x. So the only way that would happen is if I had a negative 2x and a negative 3x. Alright, so let's try that out. If I made this a negative 2 for a negative 2x, if I made this a negative 3 to get negative 3x, will I get positive 6? Yes, because a negative times a negative is a positive. So this is the correct factorization. So now that I have factored it, what I need to do is I can set these two factors equal to 0 and find the two solutions. So I'm going to go x minus 2 equals 0, and I'm going to set x minus 3 equal to 0. So over here, I need to add 2 to both sides. And here I'm going to add 3 to both sides. So that's going to give me x equals 2 and x equals 3. Alright, those are my two x values. So we need to find the y values that go with them. Remember, these intersections are points. They're ordered pairs. I need an x and a y and an x and a y together. So I like to look at this part as a table of values. So to get the y's, we're going to come back to that lonely little equation that we haven't seen since the beginning. But again, I'm going to look at this as a table. So I need x's and the y's that go with them. Okay, so I have these two x values. X is 2, and I have an x value of 3. Now I need the y value that goes with it. And I'm just going to use this little equation right here. Alright, y equals the opposite of x. So if I substitute in 2, then that means y equals negative 2. Alright, it's just going to equal the opposite of whatever x is. And if I put in 3, then that's going to become negative 3. So that means my 2 points are going to be 2 comma negative 2 and 3 comma negative 3. So these are my intersections. These are my solutions to the system. Okay, so very quickly, let us verify this graphically. Alright, so let's graph our line and our circle and see if they do intersect at the 2 points that we just found. So let's start with the line y equals negative x. We can look at this as slope-intercept form, like y equals mx plus b, by saying, okay, this is like y equals negative 1x plus 0. So that makes 0 the y-intercept. So there's our y-intercept. Now this slope of negative 1, in fact I can look at it as negative 1 over 1, so I can have a rise and a run. This means down 1 over 1, down 1 over 1. Okay, so from the y-intercept I can go down 1, right 1, down 1, right 1, over and over again, and I can clearly see where this line is. Okay, and I can continue the pattern to the left as well. Alright, so your line is going to look like that. Now it's time to draw the circle. Let's graph the circle. So here's my circle equation. Hopefully you can see that the center is going to be positive 6 comma positive 1. Right, the opposite of both of these. And my radius is going to be 5 because this is the radius squared. So let's graph a circle with center 6 comma 1. So 6 comma 1 would be right here. Now if I do radius 5, that means I should go 5 to the left and 5 up and 5 down and 5 to the right. So my circle is going to be right here. Alright, use a compass if you have one. Why not? Okay, so there's my circle. Now we are looking for the 2 intersection points between the line and the circle. And it's a little bit tough to see because they're so close together. But it seems that we have an intersection point here and another intersection point here. Okay, so that would be the points. This first one right here is the point 2 comma negative 2, and then this point right here is the point 3 comma negative 3. Alright, how does that match up with what we found algebraically? Oh yeah, 2 comma negative 2 and 3 comma negative 3. So that's how you solve a system of equations involving a conic section like a circle. We did it algebraically by doing substitution, and we also verified it graphically by graphing the line and the circle and just seeing where they meet. Here endeth the lesson. Sneak peek, in the next video we're going to have 2 circles, so that should be interesting. We're going to see how to solve a system and find the intersection of 2 circles. Alright, I'll see you on the next video.